Bless you. Okay, most of y'all looks like got a pretty good answer. I'm scrolling through there. Let's see one or two that are bad. You could have used by hand or by matrix, either one. I know I saw a lot of you doing the matrix, and that's fine. I told you I don't have a problem with that. We are going to spend some time doing different matrix operations today, so you're going to want to keep those calculators handy. I actually work it out by hand on the board, so just watch that so you can be reminded of all the steps of doing it by hand, just in case batteries run dead or something.
Alright, any of these variables would be fairly simple to eliminate. I can make all the x's with 2x's and eliminate those. I can make all the y's with 2y's and eliminate those. But the z's are already ready. They're already all on 1z, so I don't have to make them be anything. So that's what I'm going to eliminate first. I'm going to put these first two equations together and eliminate the z's. That's going to be x plus 2y plus z equals 4. 2x plus y minus z equals negative 1. Now these are different signs. This is an addition problem. X and 2x is 3x. 2y and y is 3y. Z and negative z is gone. 4 and negative 1 is 3. So there's a new equation, number 1. Don't lose it. Now I've got to get another new equation with no z in it. So I'm going to put the second and third one together. So I'm going to have 2x plus y minus z equals negative 1. X minus y minus z. Minus up there. X minus y minus z equals negative 2. Now the z's have same signs. So this is a subtraction problem with same signs. 2x minus x is 1x. Y minus negative y is a positive 2y. Negative z minus negative z is nothing. Negative 1 minus negative 2 is 1. So there's new equation number 2. Don't lose it. Now I've got to take my two new equations and put those together to eliminate a variable. Looks like the easiest thing for me to do is to keep my first equation like it is. Multiply my second one by 3 to eliminate those x's. So that's what I'm going to do. Rewrite this first one here. 3x plus 3y equals 3. Multiply all of this one by 3. It'll give me 3x plus 6y equals 3. My 3x are the same sign, so I'm subtracting. 3x plus 3x is nothing. 3y minus 6y is negative 3y. 3 minus 3 is 0, which gives me y is 0. And now I can take that y is 0 and plug it back into one of my new ones to figure my x out. I'm going to plug it in the second one right here. X plus 2 times 0 equals 1. 2 times 0 is 0. So just x equals 1. So we got an x, we got a y, find our z. We got to take both of those back to one of our original equations. Okay? So I'm going to plug it back in that first one up there. It's going to give me x, which is 1, plus 2 times 0. So 2 times 0 is nothing. Plus z equals 4. Subtract my 1. And z is 3. So my final answer is x, y, z.
You got some music going in the background. Yeah, we didn't have the radio playing that day. Alright, gonna look at some matrix stuff today. Pretty simple stuff. I always wonder about when people use matrices. The definition of a matrix is just a way to organize numbers. So, I don't know, like spreadsheet type stuff, but I don't know for sure exactly when it's used, but they are easy to work with, so it's a easy thing for y'all to do well on and get a decent grade on. wrong one. There we go. Alright, what I got here, we talked about some of the basics of matrices yesterday, how we label them and everything. There's a 1, a y, and a 3, and an x, a 5, and a 4. That matrix is equal to this one that has a 1, an 8, and a z, and a 2, a 5, and a w. Alright, so first off, before we start figuring missing stuff out and all that kind of business, what size are both of those matrices? Other way. 3 by 2, because it goes rows first. So there's 1 row, 2 row, 3 rows. So that'd be 3 by, and then columns, 1 column, 2 columns. So those are both 3 by 2s. When we get into adding them and subtracting them and multiplying them and dividing them, which we're going to do today, we have to be able to figure out what their dimensions are, because that tells us if we can multiply them or not, if we can add them or not, all that kind of stuff. Okay, but these are the same. So what we know, they tell us here, pretty simple, this is like 4th grade right now, they tell us that those are equal, so we know that the corresponding spots have to be equal. So you look there, you see top left is a 1 and a 1, right? So now you can figure out all your missing unknowns. What would y have to equal? No? Y's in the left middle. 8's in the left middle. Sorry, I thought you said 3. I apologize. You having a bad morning, Austin? You weren't your cheerful self when you came in. You all right?
Yeah.
What would x be? 2. Very good. X is in the top right. 2's in the top right. So we got all the unknowns out of there. We got a z over here. What would z be? 3. Bottom left. And w would have to be both. Bottom right. So easy stuff on that. They could make up a short little equation if they wanted to put in one of them an expression. See if they do that in this lesson. I don't remember. Those showed. Yeah, let's look at that. That's a fun problem. Alright, here we've got a plus 2 in the top left, 8k in the bottom left, 3z plus 1 in the top middle, 0 in the bottom middle, 5m in the top right, and 3 in the bottom right, plus, getting difficult here, 3a in the top left, 2k in the bottom left, 2z in the top middle, and 5 in the bottom middle, 5m in the top right, and 6 in the bottom right, equal to 10, 10, negative 14, 5, 89. Alright, this is pretty simple. This is about as, before we get into the multiplication and all that, this is about as hard as they can try to make these. Same concept that we did on the previous screen. You're going to compare corresponding spots. So I'm looking at all of my top lefts right now. Those top lefts, that reads a plus 2 plus 3a equals 10. It's everything in the top left, right? Now you combine some like terms. You got 4a plus 2 equals 10. Now you got a 2-step middle school equation to solve to figure out what a would have to be. Good. So 4, I'm already writing what I'm subtracting. 4a is 8. So you know your a would have to be 2. Alright, I want you to figure out z, m, and k. See if you can figure out z, m, and k. Got them? Need another second? I think I've got my 3 equations to solve for those. I think I've got those set up. Let's do the red one first, down there with the z's. I have 3z plus 1. And this is not always going to be a plus here. You would follow whatever sign's here, but we got a plus, so plus 2z equals, that was top middle, so top middle is negative 14. So down here on my red, that would get me 5z plus 1 equals negative 14. Two-step middle school equations. Subtract your 1. 5z is negative 15. So what'd you get for z? Z would be negative 3. How'd you do on your z? Get it? Pretty easy stuff. Alright, let's do that green one up there to figure our m's out. The m and the k were less steps because it ends up being a one-step equation after you combine your like terms. 5m and 5m just got you 10m. So all you had to do on that one was just divide by 10. Everybody get 8 for m? Okay, k was the same way. 8k and 2k is 10k. So I got my back pocket right now. So k was 1. Alright, good stuff. Easy schmeezy. I got 2, 4, 3, 6 plus 0, 8, 5, 7. Now all this matrix stuff that we're going to do can be done by hand and by calculator. Some of the multiplication ones, when we get into that in a little bit, I'll do those by calculator because their steps take so long. I'll show you how to do them by hand, but then I normally do them by calculator. But these addition ones, they're pretty simple to do. What I need to know when I add and subtract, though, I can only add and subtract matrices if the matrices are same sizes. Because you can't match up corresponding spots if they don't have corresponding spots. Right? So right now I've got 2 rows by 2 columns. Here I've got 1 row by 1, 2, 3, 4 columns. So those are not the same dimensions. Bless you. So I can't add those. So if they tell me to add that, I'm just going to write not possible. Got to be the same dimensions to add and subtract. Okay, there's a different rule when we check multiplication, but for adding and subtracting, they got to be the same sizes, the same dimensions. Alright, so if I had 1, 2, 9, negative 4, 5, 3, minus 6, 1, negative 2, 1, 0, 8. Okay, first thing before I start trying to subtract is, can I subtract those? Okay, they're both, very good, they're both 2 by 3s, right? 2 by 3, 1, 2, 1, 2, 3. So yes, you can subtract those. So our answer matrix is going to also be a 2 by 3, and all we do now, since it's subtraction between them, subtract corresponding spots. So top left, 1 minus top left, 6 gets me top left.
Negative 4.
Negative 5. Good. It doesn't matter what order you go in as long as you correspond and put them in the corresponding location. So some people go across the top and do rows, some people do columns, doesn't really matter. I'm going to go down and do this 2 next, bottom left. 2 minus 1 is 1. Put it in the right spot. What do my top middle be? 11, because 9 minus negative 2. I think a lot of y'all were saying others couldn't hear you. What would my bottom middle be? Negative 5. Tell me if you don't know any of that. What my top right? 5, and the last one, bottom right? Negative 5. Pretty simple, pretty good. And you could do that in the calculator. Like I said, the adding and subtracting ones are pretty, I can do those faster than I can type them in the calculator. When we get into some of the big multiplication ones, though, that's when I'm going to get the calculator out with you. All right, this next one, though, I'm going to do without. It's called scalar multiplication. Scalar multiplication. I don't know where the name came from, but I'll tell you what it means. All right, scalar multiplication in Coach Wright's dumb words is distributing. You've got a number right next to the matrix. You're told to find the product, so all you're doing is taking that number just like you would if it were a parentheses, taking that number outside and multiplying it by everything inside. In the matrix world, that's called scalar multiplication. So we're going to take 2/3. My answer, since this is a 2 by 2 matrix, my answer will be a 2 by 2 matrix. We're going to take 2/3 times 18. It's 12. We're going to take 2/3 times 9. 6. Good, Nathan. 2/3 times 24. What did I say? Is it Austin? Sorry, Austin. 2/3 times 24 is
18.
16. Is it 18? I think it's 16.
No.
And then 2/3 times 12? Be 8, yep.
Yeah, I did 1/3.
You're good. Okay, everybody good? Pretty simple. I don't know where scalar came from, but all it means is you distribute it to everything. Alright, now, when we multiply matrix by matrix, are you ready for that? I'm going to show you. Oh, I need to go back. My bad. I'm going to show you by hand, and then we'll do it in our calculator. These are the ones that I'm generally doing in my calculator if it's bigger than a 2 by 2. 2 by 2 by 2 by 2, you can handle that pretty simple. But all right, I've got matrix A. I'm going to label these because it's going to change the way we work it. Matrix A has a 1 and a 7 and a -3 and a 2. Matrix B has a 1 and a 3, a 0 and a 1, a -1 and a 4, and then a 2 and a -1. Alright, so before we start multiplying, I got a couple of questions. First off, in order, normally in Plano numbers, multiplication is commutative. That means the order can go in either way. 4 times 2 is the same as 2 by 4. That's not true in matrices. Multiplication with matrices is not necessarily commutative. Okay, here's the reason why. I want to check and see, can I multiply these in the order of A times B? Okay, here's what we have to do to check. What dimensions is matrix A?
2 by 2.
It's a 2 by 2, so I'm going to write 2 by 2 here. What about B?
2 by 4.
2 by 4, good. For me to be able to multiply these, when I wrote their dimensions, I need to scoot that up so you can see it. When I wrote their dimensions down here, the middle two have to be the same. So you got to put them in the order it asks for, and then those middle two have to be the same. So yes, 2 and 2 is the same there, so it is going to be possible to multiply them. You know what dimensions the answer will be? It'll be those outer ones. So A times B, when I multiply that in a second, is going to end up being a 2 by 4. Okay, is it possible to multiply B times A? Okay, you told me B was a 2 by 4, right? You told me A was a 2 by 2.
No.
So now you see you got a 4 and 2 in the middle. That's not the same, so that one would not be possible. So we got to stay, this one has to be the A times B. Alright, so are you ready to start doing it?
Let's do it. Do it.
You got any notes I need from that? Can I erase that?
You good.
Alright. Shaking here. What we're going to do, I'm going to take each one of these, the top row of A, I'm going to take my row to every column of B. Then I'll have to come get my bottom row of A and take it to every column of B. Okay? So I'm going to start off here. I'm going to have top left 1, times, I want to highlight, but I'm going to end up with everything highlighted when I do that. 1 times 1. Okay, then we add that to negative 3 times 3. So we've done top row to top column. Okay? So that got me top row, top row, first column, top row, first column. So we've done top row to first column. Okay? Now I'm going to go top row to second column. That was interesting. 1 times 0 plus negative 3 times 1. Okay? Top row, second column, top row, second column. I'll just start squishing these together. I'm going to run out of room. Alright, now we got to go to the third column. So I'm going to have 1 times negative 1 plus negative 3 times 4. Top row, third column, top row, third column. And I've got 1 row or 1 column left. I'm fixing to squish all this together so I can get it all in one. So I'm not changing anything, just trying to save some space. Angie, if y'all could behave, I'd appreciate it. Alright, so my top row to last column now, I would have 1 times 2 plus negative 3 times negative 1. Okay, all of that came from the top row, and all those answers are on the top row. So now we're going to do the same with the bottom row, and it's all going to go on the bottom row. Alright, are we ready here? Now, bottom row, what's going to be cool is the bottom row is 7 and 2, so all that's going to change, the 1 and negative 3's are going to change to 7 and 2's. Everything else will stay the same. Because that's 7 times 1 and 2 times 3. So here in the second spot, I'd have 7 times 0 and 2 times 1. So in the third spot, I have 7 times negative 1 and 2 times 4. And then 7 times 2 and 2 times negative 1. Okay, don't worry, I am going to go over the calculator with you. You'll figure it out faster than I do. Now, got to just do the addition and multiplication in there. So top left, I've got 1 times 1 plus negative 3 times 3. So 1 plus negative 9, so I should end up with a negative 8 there, right? You want to go across or down? Across, 1 times 0 is 0. 3 times negative 1 is negative 3. 0 plus negative 3. 1 times negative 1 is negative 1. Negative 3 times 4 is negative 12. I add that, I got a negative 13. 1 times 2 is 2. Negative 3 times negative 1 is 3. I add that and get a 5. Okay, we're good on our first row. Second row. 7 times 1, 2 times 3. I add those, that's 13. 7 times 0, 2 times 1, I add those, and that's 2. 7 times negative 1, 2 times 4, I add those, and that's 1. 7 times 2, 2 times negative 1, I add those, and that's 12. So that would be my answer. 2 by 2 is not bad. That 2 by 3 and a 2 by 4 wasn't bad, but you can get into these where it's like a 4 by 4 times a 4 by 4. the steps on those when you have to multiply everything in each row by everything in each column can get a little bit more tedious. So that's when I would be using a calculator. Rick's going to show you how to do one on a calculator now, and you'll figure it out. It's pretty simple. You got what you need on that? No, too slow, too fast? Alright, let's look at if we wanted to multiply negative 1, 0, 0, 2, 3, 1, 0, 2, 4. I'm going to multiply that by 2, 0, 3, negative 1, 2, 0, 2, 1, negative 1. Alright, so for my options to do this by hand, I would have to take top row times first column. So I'm not fixing to do this, but just so you know what the process, I'd have to have negative 1 times 2, plus 2 times 0, plus 0 times 3. That would all be in my top left. Right? Then I'd have to go 2 times negative 1, 2 times 2, you have to do that for that whole deal there. To hit that in the calculator, let's see if old ladybug will work today.
So I don't understand how you know what to multiply by on the.
What do you mean, Bailey?
Why was it 1 by 1 and 3 by 8? Like, how does that?
Let me get back over there. I started with the top row and went to the first column. So I did my 1 and 1, and then that meant the negative 3 and 3 had to go. So you take the top row to every column. That's what we did across the top.
Okay.
Does that kind of making sense?
Yes.
Alright.
Sorry.
That's okay. I'm glad you're paying attention and asking. Let's see here if we can get the. Yeah, I got a nice glare in the middle of it. Let's see what happens if I turn the lamp off. Can't see it. So you want the glare or you want the. Guess we'll go with the glare. Alright, I'm going to do this the way Blake and Austin showed me yesterday. That's going to be a lot easier using that alpha zoom function. So I'm going to hit alpha zoom. Okay, and some of the newer calculators, that menu looks a little bit different, but it's still the same. So then I'm going to, this was a 3 by 3, so highlight 3 and 3 and tell it okay. And then fill these numbers in, which, make sure, is it negative 1, 0, 0? Is that the one we did? Column 1?
Negative 1.
Okay. So we got negative 1. I'll go across 2, 0, 0. Whoops, not decimal, dummy. 0, 3, 2, and 0. 1, 4. Okay, then I got outside of that matrix. Now, I want to multiply that, so I'm going to hit times. Now I'm going to hit alpha y equals and go do the matrix again. Go put the one I'm multiplying it by. So I'm going to, not y equals, that's a fraction menu. Alpha zoom. Alpha zoom. I got alpha zoom, and I'm multiplying it by, oh, still got to do my 3 by 3. Don't forget that. I about did. And I'm multiplying it by 2, negative 1, 2, 0, 2, 1, 3, 0, negative 1, hit enter. it over the, there we go. Is that what y'all got? I like that. I save time on that. That's way faster and way simpler. If you type a number in wrong or miss a sign, you're going to miss it. Same as if you make a mistake on your paper, you're going to miss it. All right. There's not a whole lot more to do with that kind of stuff. We are going to still look at inverse. We're going to still do inverse. I don't remember. Maybe I was supposed to do inverse today. Let me look.
We did it first.
We did kind of. You're right. I did kind of. I'm solving those.
Yeah.
All right. So let me just do one more thing real quick. Still going to be using that calculator there. If we were asked, should we go back? If we were asked to simply find the inverse, we did inverse yesterday when we were solving the 3x3s in our calculator. That's what Kelsey was talking about. We actually did the inverse then. But if you're ever just asked just for the inverse, like if we had matrix A that is equal to 5, 2, and 2, 1, and you're asked to find the inverse. Okay, I'm going to do that in my calculator as well. So, 5, 2, 2, 1. Y'all ready? I'm going to go here to alpha zoom. That was a 2x2. Is that the right one? Did I type it in? Oh, y'all can't see if the glares are on. Is that the right one? Okay. Now to get the inverse of it, I've already moved my cursor out of it. See the cursor over there flash on the side? So I'm just going to hit the inverse button, which is the x to the -1 power right below math. So I hit that button, it brings up that little -1 up there, and hit enter. And there's the inverse matrix. Now, not all matrices have an inverse. If it would have given me an error there, I would just say that it didn't have an inverse. Then there is one more thing I want to show you. It's called the determinant. Okay, so we got inverse, determinant, and I don't use matrices enough to know what all this stuff is used for, but you are going to be asked possibly to find the determinant of something. So there is a formula. It's pretty simple on a 2x2. It's just multiplying diagonally and then subtracting. But when it gets to be a bigger one, a 3x3 or something, it's a little bit more difficult. So let me see here. Let me find a good one to find the determinant of. Alright, so if I had -1, -3, 2, 2, -2, -1, 4, -3, and 5. And I'm asked to find the determinant. Okay, I was just playing with it on my calculator to make sure I was going to tell you the right thing before I told you. Alright, we're going to find the determinant of that. Steps are going to be a little bit different. Before I just put the matrix in, I need to tell it that I'm fixing to find determinant. Okay, so to get to determinant, go to your matrix menu, which is not the alpha zoom, so don't alpha zoom yet. Go second, and then matrix, which is on that inverse key. Remember that we brought up that menu yesterday when I didn't know the shortcut yet? Are you there? Okay, if I'll move it over to math, the first thing that comes up, that DET, that stands for determinant. So I'm going to choose, hit enter and choose that. Now I'm going to go type that matrix in the way Blake showed me yesterday. So I'm going to hit alpha zoom, and it's a 3x3, so make sure you change that to a 3x3. Should have something looks like that. Okay. We had a -1, a 2, a 4, a -3, a -2, a -3, a 2, a -1, and a 5. That's it. On a 2x2 matrix, the determinants, all you do is multiply diagonally and subtract. On a 3x3, it's a zoo, because you have to go diagonally from every spot. Okay? I've actually in the past showed, but I'm not even going to do one now, because you have to go diagonally here, which is the simple one. Then you have to go here, and then that loops back around. And then you got to go here, which loops back around. Then you got to go here, and it's... Yeah. So I do those.
I don't even know.
Yeah, I do those on the calculator for sure. Okay. All right. Everybody, all right? Not a whole lot more you can do because so much of that is faster just to type into the calculator. All right, that'll be it for today.